let's take a quick look at the Polkadot ecosystem and explore available networks for building an NFT application. To do this, you may visit the polkadot.js.org/apps portal, and here you will find the list of available networks. The first two are Polkadot and Kusama. Both of them are production networks, so let's skip them. Below you will find Vasten and Paseo, which are testnets. So if you want to test your application in an environment similar to production, I recommend you to go with Paseo, because Vasten may be a bit unstable in the moment. Now, every network in the Polkadot ecosystem consists of a relay chain and a list of parachains, which are sort of layer 2 networks. The key one for us is Asset Hub. Asset Hub is a system parachain for assets in the network, of course, including NFTs. This is where we will meet our NFTs. You will also find a list of available nodes here, and you can choose any of them. And yeah, here in the URL, you will find an RPC endpoint. So this is what you will use to connect to the testnet. Now let's quickly talk about wallets. I am using the Polkadot.js wallet here. This is kind of very basic wallet for Polkadot. Of course, you can use some more advanced options, more advanced wallets. And yeah, here you can see that I already connected some accounts to the portal, and one of them has some Paseo tokens. And because Paseo is a testnet, you may also receive these tokens for free. For that, you need to visit facet.polkadot.io. And here you need to choose Paseo for network and Asset Hub for the chain, and put your address here, and that's it. Basically, you will receive your test tokens for free. I will not go through this process because I have plenty of these Paseo tokens, but basically that's it. That's how you get started with Polkadot and Asset Hub. So finally, testnets are great way to test your application, especially before deploying it on the mainnet. However, testnets are not always ideal option for development, right? Because at least because they can be very time consuming. And later we will see how to run our own local blockchain, which will work almost instantly. NFTs on Asset Hub work differently from what you might expect. Like traditional NFTs, they are not smart contracts, and instead they are native assets on the blockchain. Now let me show you how it is easy to build the NFT collection on Asset Hub. For that, I will go to the extrinsic section, and here I will choose NFTs, create method, and let me sign this transaction as this. So I don't want to explain these extra configuration options because we understand them better on the future steps. Just let me demonstrate that my NFT collection has been created. And here, let me show you the events, and here the event for the created collection. So you may see that my collection has a collection ID 63, and that is the unique identifier for the collection. So it's not an address, but it's collection ID's number. I will use this collection ID to create my first NFT for this collection, and again I will go to the extrinsics NFTs, and now mint method. I will put my collection ID here. It's 63, and I can choose an item ID. I can choose any available ID. I will go with 1. Let me sign this transaction. And again, we need to wait a bit. And yeah, that's it. My first NFT in the collection 63 has been created. There are a few different ways to send transactions to the network. The most common ones are Polkadot.js and Puppy. These tools provide low-level access to the Substrate API, which means they require some configuration and boilerplate code for sending transactions and handling responses. Another option is to use the unique SDK, which is specifically designed for NFT use cases. This SDK provides a simple and efficient way to create NFTs on Asset Hub. The SDK consists of 2 main components. First is an HTTP server, which connects to the network and provides an HTTP interface. And the second one is a TypeScript library, which simplifies sending requests to the HTTP server. You can use publicly available endpoints or run your own local SDK. So actually, we'll launch our local SDK server against our local blockchain, but now let me show you where you can find SDK materials and give you a quick overview of the SDK HTTP server. So first, you can find the official documentation at docs.unique.network. Here in the build section, you will learn the basics of how to install and connect to the SDK. Additionally, if you want to learn how the SDK works with Asset Hub, there is a dedicated section for that. And finally, here in the reference section, you will find the list of publicly available endpoints for the SDK. Since we are building on Paseo, I'll select the Paseo endpoint and explore its available methods. For that, I will go to the documentation, which is Swagger UI. So here's how it works. The REST server provides methods for sending transactions and querying data on chain, and it acts as a proxy. So by formatting your HTTP requests correctly and forwarding them to the network. Now let's see in action by querying an account balance. For example, here is my account, which has approximately 5,000 Paseo tokens. I copy this address and send the request. Yeah. Now that we have explored how Asset Hub and the SDK work, let's tap our local environment. For this, we have created Asset Hub next template. And inside, you will find a Docker Compose file that launches our entire local environment. This setup includes 2 services. The first is Asset Hub Chopsticks. So Chopsticks is a great tool by Akala that allows you to create a local fork of an existing network. And the second service is SDK HTTP proxy server that will interact with our local blockchain. Now let me show you how Chopsticks works. Here we have Kusama Asset Hub configuration file, and here's what's important. First is endpoint. So in this case, we are running our local fork network based on Kusama using this existing URL of an existing node. And below you will find a list of accounts with preset balances. And if you want, you can add your own account to this list, or you may use one of the existing accounts. Now let's return to Compose for a moment, and let's notice that our local asset hub will be launched on port 8002, and our SDK will be launched on port 3333. Now let's start everything up and see how it works. So here in the root of the project, I will run docker compose up. And yeah, so for me, it launches almost instantly because I already built these containers previously. But you will have to wait a bit until both services are up and running. And once they are ready, so we can return to the Polkadot JS interface. And here we need to set up a custom endpoint. So as we remember, our chain is running on localhost 1802. So let me set correct port here. And yes, here we need, so here is our local blockchain, and you may see that I have some accounts with really big balances. Now let's execute some transaction just to check that everything works correctly. Let me send some tokens from Alice to Bob. Example, 1000 KSN tokens. Sign this transaction, and we need to wait a bit. So the first transaction executing for some time. We need to wait a bit, and yeah, it's included the block. Yeah, and the Bob's balance has increased. So the next transaction will be executed much faster. Let's check it. Yeah. So now when we sure that our blockchain works correctly, let's check our SDK. So we remember it's launched on 3333 port. And let's also execute this. Let's also query balances. And here let me actually query Bob's balance. I am expecting it would be 102,000 KSM. We'll put this address here and execute. Yes. Great, it works. To efficiently interact with the SDK server, you can use the unique NFT/SDK npm package. Let me remind you that the SDK documentation can be found at docs.unique.network. I'm not going to explain how this package works because it's pretty straightforward and the documentation explains it well. Instead, I want to show you the alternative way to explore how this package works, as well as how NFTs function in Asset Hub in practice. So we will do this by exploring a test suite, which you can find at src tests sdk.test. But before we dive into the tests, let's talk about metadata. So metadata is information related to an NFT, such as traits, that defines properties and value. So the NFTs palette supports two types of metadata. So first is on-chain metadata or attributes. These are key value pairs stored directly on the blockchain. And the second type of metadata is off-chain, which is similar to the Ethereum version of metadata and most often stored in IPFS, typically following the OpenSea standard. If you are unfamiliar with this format, you can find the link to this to where this metadata format described. And for off-chain metadata, we need some third-party storage. So for this example, we will use Pinata and its SDK. To use Pinata, you need to create an account at pinata.cloud. After that, you need to generate API keys. Here, let's do this. When your key is generated, you need to copy your secrets. For this example, we need JavaTech key. And you need to put them into the .env file. You can create one using the example of .env.example. Already created one. So you need to put your Pinata JavaTech token here, as well as API gateway, which you can find here. Here is your gateway. You put it here. And that's it. You are ready to execute your tests. So before running tests, make sure that your local environment is up and running. So if not, execute Docker Compose up. And yeah, let's observe tests. So this test suite contains three different tests. The first demonstrates how to build and upload metadata to IPFS using the Pinata SDK. The second test shows how to create an NFT collection using the SDK and sets its metadata. And finally, this third test demonstrates how to mint an NFT and set its metadata using the data uploaded in the first test. Now, you can use Visual Studio Code to debug this test. You just need to install this VTest Explorer extension to be able to debug these tests with breakpoints. So if you want to, for example, if you want to learn how the balance query works and what would be the response here, you may put the breakpoint here and just execute this test. Now that we have set up the entire infrastructure, let's see how everything works together on the front end. First, let's make sure the .env file is correctly configured. You should already have the next public REST URL variable set. In this case, it's set to localhost 3333, which, as we remember, is the address of our local SDK server. And we will leave it as this, but if you want to test your app on the real network, you can set it to one of the public endpoints listed in the documentation, and here is the link. And before we proceed, let's double check that our infrastructure is running. I will execute a docker ps command here. This lets me confirm that both containers are running. The first one is for the unique SDK server, and the second one is for our local blockchain powered by Akala chopsticks. And actually, let me show you the logs of the SDK. We'll launch docker logs minus n for 500 rows and minus f follow. And yeah, so I will leave these logs for a while. Now we are ready to start our Next.js application, and I will do this by executing yarn dev. Of course, you can use whatever package manager you prefer. Yeah, and this will launch the Next.js application on port 3000. Let's open it in the browser. And yeah, as you can see, this is a very simple application. For this framework, we have prepared a template application that already handles account connections, and it integrates with the SDK. You can see that it consists of a single component called Polkadot Wallet Selector. And okay, let's play with this demo a bit. So to interact with the app, you need to have one of the supported wallets installed. If you don't have one, follow the link in the UI to install one. But because I already have Polkadot.js wallet, I'll be using this wallet. Okay, here I'll connect my accounts. And I can switch between them. So as you can see, our Bob's balance is something around 101,000 KSM tokens. Let's double check this value by navigating to Polkadot JS portal. And yes, the balance is correct. Okay, now let's test everything together by sending a transaction. So for that, I will copy Alice's address and put it here, and I will transfer, let's say, 1,000 KSM tokens. I'll submit this transaction, and yeah. Since we are running Akala chopsticks, transactions executed almost instantly here. Now let's check that our balances changed. So Bob's balance now equal almost 100,000, and yes, that's correct. And here in the Explorer, you will find events related to our transfer. So everything is working smoothly. And basically, all the boilerplate code is actually done, and you just need to create your own components here to solve this challenge. Now let's actually do one more thing. Let's check our SDK logs to see that our transaction were actually went through the SDK. And here you will see some logs related to balances querying. And somewhere here, yeah, we can see some logs related to balances transfer. So yes, basically that's it. Our SDK works correctly and all our transactions are go through this SDK server. Now, finally, let's make a quick walkthrough the existing code base, and I will show you how this application works. It's basically the entire application consists of a single page, which you will find in at src slash app, and here is page 6. So and on this page we have basically one important component, which is Polkadot wallet selector. We already saw it. And also there are two main providers, one for accounts, which is called accounts provider. This provider handles wallet connection using the SDK utility methods. And the second provider is for SDK interactions, called unique SDK provider here. So it's very small. And okay, so everything is straightforward and easy to integrate. And now that we have our front end connected, we can start customizing this application. And yeah, happy hacking.